All right, so last week we went over fixing the prefabs, fixing the color and speed elements of our UI. Now every part of the UI works. I stress tested, I played with everything, I fixed the prefabs, made sure that every slider, drop down, every UI element actually interacted, did something. We added kind of memory to our prefabs. We did some, we added a script at the root of all our prefabs to kind of record the initial data, the randomized data for the animation timing and the color information so that we could reference that later. And we updated our change speed, change color, change emission, change opacity, and just did some general code cleaning. And for this week, I just got to finish up the last parts of the script, which were randomizing the spawn timing and speed, basically this section right here. And then just going through the rest of the script and answering any questions. General tech help, where you're stuck. And you need to drop sprint 4 here, basically a week from now, Sunday night, midnight. Then come in, take the exam, and you can hang out afterward. I'll just do like general tech help if you need help. So this Sunday, you can drop sprint 4. I'll go over again the deliverables on that. Then Monday, you come into your regular class time. So 11:30, 1, 2:30. I got to email the 11:30 class that they're supposed to come in.
Coming in at 1?
No, 11:30.
Oh,
Otherwise, there's too many. If everyone comes in, there's too many. So then we do the exams, and that's it. I'll have lab times as normal, so that's Monday, Wednesday, Thursday. For those who got to continue work on their project, and then after that week, so that means the 6th lab, 8 lab, 9 lab, no, 4 to 6, what have you. Email me if you need to meet any of these other days, and then past this week, it's only email and web conferencing. If you need to keep working on your projects. So yeah, sprint 4. Sunday, final exam, Monday, hang out after the exam if you need help. I'll just be here all day, lab times as is next week, and then after that you got to email me. All right. So, is there any questions on that before I show the project? Yeah. Yeah, for you, it's one. Yeah. For him, he's in the 11:30 class. He comes in at 11:30. So, here's my posting. These are just all the major features that we're working on this week, or this sprint. And it's more about making everything work and clean up, optimize. So there was no new features. So again, there's no user flows. But I did want you to just give a little description of your project and then pick 2 parts of your code. Take a screenshot. It might be a few lines of code. It might be 5 lines. It might be 10 lines. It's a section of your code that you're interested in, that you fixed, that you cleaned up, something that you can actually discuss. What is this code doing? And just describe it in plain English. I'm grabbing this variable, I'm storing here, I'm allowing the user to access the color here, and this is what this is doing. Actually describe to me what these lines of code are doing. So if I look at the code and you're saying, hey, look at lines 6 to 13 in this screenshot. And this is what it's doing. And you just write back to me what it's doing. Do that in 2 parts. So each description of your code should not be more than a paragraph. So aim for a paragraph description on one part of your code, aim for a paragraph description on another part of your code. Actually show me the screenshot, a JPEG that's viewable in your Moodle posting, nicely sized. And just be like, hey, I'm showing this part of my code. I'm going to talk about lines 6 to 13. This is what it's doing in just plain English. It's kind of like a sanity check. Can you just describe some parts of your code? That's it. And then the link. And so in this case, here's my link. It opens up a new tab, doesn't overwrite the Moodle tab. Click play, it works. Here's my UI, it animates. Sure, that's great. And there's my painting program. And now for today, I got to show about randomizing the type and randomizing the destroy time. Just going through the rest of the script, whatever questions you have. All right. So that's the deliverables. So I expect you to have a link to your working project, a nice image showing your code, and a paragraph description showing it. Just a nice image showing another part of a code, another description on it. Sound good?
And how much fixing do you want?
Fix it with the level of fixing I'm doing. Like all my, I went through each part of the UI. I was like, ooh, why isn't this working? And then I had to go in and look at, and I actually went through these last 3 weeks, or 4 weeks, or whatever it's been, and I fixed everything. So that's the fixes I'm talking about. At the end of the day, you got 3 prefabs. All of them are 3 different types of paint strokes. Each of them have an animation that can be played, 3 separate ones, and no matter what I'm messing with on your UI, it actually does something. It's not functional. All right, and then here, and you should have gotten your Sprint 3 grades too. And so here's Sprint 4. And when I'm done today, I'll post up the lecture here. This is the last lecture. And then here we come in for the exam. And so let me just go over the new part, or the last remaining parts of the script I haven't done. And then let me just see what random questions you have. And then any remaining time, we'll just go over the final review. All right. All right. So probably at the end of this class, I'm going to end up reorganizing these. Like usually private variables should be grouped together. Public variables should be grouped together. You had a question? So I'll probably reorganize this area. It's just gotten messy. It's just organically grown as I've been building out the features of this. Sometimes you'll see a situation where all the variables that are needed for the most important method is kind of moved to the top of the class. All the variables that are needed are kind of listed before that method. And then if there's any variables, so as we move down here, this update method is like the most important part. And then down here, we just have a bunch of methods dealing with the user interface. If I keep going, change, destroy, which is actually called by the UI. So all of this is UI related. So if there happen to be variables that are just needed to keep track of all these UI methods, you can put them here. So you don't need to put all your global variables in front of all your methods. It's just, are they outside of these methods? If all these variables are outside of the methods, they're available to all the methods. They're global. So sometimes you'll see like all the methods or all the variables that are needed for this first method, and then you'll see like another grouping of variables and then another method. And somebody did that to logically break up their class to show you that, okay, these variables are related to this method, this one's to this, instead of putting all the variables up top. In this case, I'm making use, I would hunt through here, and I don't think so, but if I found any variables that are very specific to a bunch of these UI methods all the way down here, then I might move them and put some comments to help break up. So it's easier for whoever's reading this to know, like, oh, some of these variables just had to deal with keeping track of all this UI stuff that's going on, and it's not dealing with this big update loop, which is more for like user input. So we got our update loop, got a bunch of if statements that we're checking. Here's my shortcut keys, 1 to 6. I don't know if I covered, I think I did 4 to 6 last week, shortcut keys. But so let me just click on my UI element here, see what the methods for this random, yep, this group here. Okay, so all I did was duplicate this section of my UI and just move it down. So it has a background image, it has a text element which is rotated 90 degrees, two toggles, and then I just grouped them nicely. So here's the toggle for randomizing the prefab type or spawn type and the time. And notice that they're named nicely. They're just positioned, and this one is change prefab time and change prefab type. So I could just read it here. I don't need to actually go into, but you can click and see which method it's connected to. So let's go take a look at these methods. So change prefab type and change prefab time. All right, so these are very similar to, they're basically identical to change animation type, change animation speed, which we ran over. They're just passing in a bool, which is coming in from the UI. If the toggle is on and you click on it to make it off, it'll pass false. If the toggle is off, nothing's checkmarked, you click on it and a checkmark happens, it'll pass in true. And so all I'm doing is I got two bools here, is spawn type random and is spawn time random. So notice is, so it's a statement that's very easy to say. If it's false, it means no, this should not be random. And if it's true, yes, this should be random. So it's very kind of plain, straightforward English sentence to know what this bool should be doing. So we have is spawn type random and is spawn time random. So if I go up at the top here, we just have this series of private bools all the way at the top, these variables. Private bool, and then I have a bunch we're checking is time destroy on. By default, it's set to true. That's our behavior for when we start. And then we have is anim type random, is anim speed random. By default, they're false. So we're not setting it. So the default value just happens to be false. And is spawn type random, is spawn time random. And now they're defaulting to false. And I set up my UI so that the toggle is not on, so that the UI is aligned with the default state of the information. So if I click on one, notice is on, it's turned off. I could just as easily turn that on, and when you click play and let it reset, there'll be a check mark that'll be active. But it's off. All right. All my random behavior is turned off by default. So where am I using it? So is spawn time type random. I'm doing the check before I go into my switch statement. So we had used them down here. You know, is anim type random? Is anim speed random? And I was doing the checks down later in the update loop when we're actually dealing with setting up the animation information for this spawned prefab. But the first piece of information that we deal with whenever we determine if the user has clicked, has initiated a user input event, is what type of object should we be instantiating from our prefabs, our external files. And then we worry about all the information that we need to set on it, like animation, scaling, position. So since it's the first piece of information we're dealing with after we've determined that the user has indeed clicked or left clicked, we need to first check if, and this is right at the top, right we figured out where our click position is. The first thing we do, should we be randomizing our spawn type or not? If not, false, which is the default behavior. We never do this. We never do what's inside the if statement. And we just go right into our switch case, our switch statement, and we evaluate which case based on the shape integer, which defaults to 0. So default case, I shouldn't say default case because that means something within the switch statement. My integer is defaulting to 0, my integer called shape. We go into our switch statement, we go to case 0. We're going to instantiate whatever painted object 000 is, our public game object reference variable, which I dragged my sphere prefab onto. So, yeah, if the user goes into the dropdown and changes the shape, and that will change this integer, sure, that's fine. But if he clicks on here is spawn type random, this will evaluate to true because we have the method called change spawn type random or whatever it's called, and which sets this variable to true when the toggle is clicked on. So what's it doing? It's calling some method that I've built called change shape, and it's passing in some information. Before I show what that information is, let's just look at this method. So here we have public change shape, which actually I placed right next to change prefab type random and change prefab type time random. So the method that we're using is right next to our UI methods to kind of give some organization here. So public void change shape int temp. Technically only this script is calling this method, so you could get away with making it private. But I think at the time I was writing the method, I wasn't sure if the UI element is going to call this method or if this script was, so I left it to public. But this might be part of my refactoring. Check if I can make this method private. Which is, you always prefer your methods, your variables to be private when you can get away with it to help with data encapsulation. So you know that no matter what, there's no way another script is going to mess with this. So what happens? You pass in some integer. We update our internal representation of the shape, our integer called shape. And then we also go and find the dropdown that's in charge of the shape, and we update its value so that we ensure that our UI is representing the same information to the user that our internal states are. Because now when we're going to randomize what this shape integer is, even before we go into our switch statement to call whichever prefab the shape is, we need to keep track of this information to the UI, or else the UI is going to be out of sync. Say we randomly set shape to 3 and the UI is still at 1. Or in its case, the first one is 0. But you can see that you can get out of sync, and then it's given a wrong. The user isn't given the correct current state of the shape. So I think this is the first time we're referencing shape dropdown, so I'm going to have to talk about this. So if I go up, public dropdown, we are already updating our anim dropdown, our animation dropdown, because we've already started to randomize our animation type, and we need to reflect that information back to the user wherever it currently drops, the last paint stroke. So we can type out shape dropdown, and we know that we're using the Unity UI library to connect to UI elements. So save this out, and when you do, your script will ask for, well, what's the shape dropdown? And this will be none. So if you clean up, you can either in your scene view click on the UI element and hopefully it'll get you close to it, or just make sure that your UI is organized and named. Here's dropdown primitive, the dropdown that's responsible for selecting the prefab. So if I go down here, dropdown, here's the value. It defaults to 0. Remember, it's just a list. I've just named them 1, 2, 3. That's the user readable string value that's shown to the user. That is not the internal number. The internal number is a list of elements, and our lists, our arrays, always start at 0. So the user sees 1, 2, 3. Internally, it's 0, 1, 2. We have a mapping from a string to an integer. We use the integer behind the scenes, but things are nice and legible for the user. And this is what's called a dictionary. We haven't built any, but this is what this is behind the scenes. So I can set this value, and when we set this value, the user sees what's happening out here. It's reflected to the user, I should say. So if I click play, if I change, notice the value is 0. The user sees 1. And if I change that to 1, the user sees 2, and so on. I only have 3 settings. So see, if I go past 2, it just still defaults to the last one. So 2, the user sees 3. 1, the user sees 2. So once you say, okay, what's this shape drop down? And then you say, oh, okay, this is it. Connect it up. Then you know that this is actually referencing something. It's not null. So if we go down here, we can actually say set its value, dot value, to whatever this integer is we're passing in. So we're updating our internal representation, our internal tracking of what the shape is, and we're updating our UI. So all that is done before we go into this switch statement. So what are we updating it to? So we've dealt with this before. We're going to do a random range, and that creates a random float from a min to a max value. And then since in this case we need an integer, we just cast it to an int. So I'm doing a random range from 0.0 to 2.99. So this means we go from 0.0 to 0. Infinity nines, or however many nines a float holds. We have a full chance of casting a 0. Same with 1.0 to 1.9 with a bar over it. And then we're doing the same with 2. Although it's 2.9, I don't feel like keep typing out the 9s. 9. That just means there's like a very small, maybe like a 1% or 1/10 of a percent chance that 2 has less of a chance of randomly being generated than a 0, 1. You would never notice it, that amount of variation of how many times you're going to get a 0, a 1, or a 2. But if you want to be really anal about it, just drop down a few more 9s. And now it's like a 1 out of a 10,000 or 100,000 times will 2 not be as expressed as many times as a 0 or a 1. But in either case, we have an equally likely chance of receiving a 0, a 1, or a 2. And that's all we care about because we only check case 0, case 1, case 2. If you had more prefabs, we would open up these, we would open up our dropdown, and we would have to be aware of more than painted object, double knot, 1 and 2. Now we have paint object 3, and so on. So we're randomly casting, getting an integer from 0 to 2. Passing that into this method, which is updating our internal integer and telling us to update our UI dropdown. And then we use that new integer in our switch case, our new randomly cast integer. And that's how we get random choice of what we're spawning. Sound good? Let me show the different parts in the script again. All right, we got a UI element. It's a toggle. Here, toggle defaults to not on. There we go. Toggle prefab type random. Toggle defaults off. It's connecting to a method in our script called change prefab type random. Change prefab type random. All it does is it sets our internal boolean is spawn type random. Is spawn type random is just a private bool that defaults to false, so it's lined up with our UI element. We do a check on that in our update loop. If the user is actually interacting with the mouse in the correct manner, we figure out where we're going to spawn something. Then we check if it's going to be random, a random prefab to spawn, before we actually instantiate. And if so, we run this method called change shape, but we pass in a random integer from 0 to 2. That change shape is another method that receives an integer. It sets our internal int, our private int called shape, which we make use of in our switch statement. And it goes out to the UI and updates the shape dropdown so that the UI is reflected of the change as well. The UI dropdown is up here, public dropdown, shape dropdown. And once you save that in your script, it's going to ask for it there. So I started this whole cycle here, toggle prefab type dropdown, and I'm ending this cycle here on dropdown primitive. And that's what I'm going to connect to my shape dropdown variable. So the UI, one part of the UI initiates this whole cycle, goes through, and then we end it by updating another part of the UI. All right, and last, toggle prefab time random. Toggle defaults to off. It's going to call this method change prefab time. It's lifetime, or the time to destroy it. So that's here. Public void change prefab time random. Pass in a bool, and we're setting our isSpawnTime random bool to that. IsSpawnTime random is just a private bool, defaults to false, and we use it here. So all the way at the end of our update loop, we actually instantiate something. We check where the position of the last spawn object was so that we can mess around with the scaling information of this paint stroke. We figure out if we have to assign colors and emission colors to the root of the prefab. We cycle through all the children in the prefab to see if we have to give them colors and emission colors. And then we also store that information in our prefab data script. Then we check if there's an animator at the root of the prefab. We see if we have to randomize the type on it. We see if we have to, then we set the state on it. Then we see if we have to randomize the time on it. Then we set the time on it and record that information in our prefab data. Then we go and parent this newly instantiated prefab underneath our click detector script so that we can access it easily later. Then we check if we should be destroying it after a certain amount of time. And I'll get to that. This is where the script is. Then we record where this current click position was so that we can use it the next time we spawn something. We end our update loop. No matter if the user clicked or not, we update the mouse position on our UI. So within that whole cycle of things, all the way at the end basically, do we need to turn on the time destroyer on this object? If this is false, the thing lives forever, and the user can, the only way the user can get rid of it is either right click on it or hit the clear all button. But if time destroy is on, which is our default behavior, we do a check. If isSpawnTime is random, we're going to do this. Else, which this is what you're used to, else destroy primitive, which is a reference to our newly created game object, not a reference to the prefab. And how long does it have to live? How long do we destroy it? Well, that's a float that we have, and I think we default it to 3. And we have a little slider that we can change that. But this is new. If is random time is random, and that only becomes true if the user clicks that toggle, then we're going to call this destroy method instead. In this destroy method, we're still going to destroy this newly instantiated game object. We're still destroying this primitive reference variable. But instead of time destroy, we're going to do a random range from 0 to whatever that time is. So time to destroy is defaults at 3. We'll get a random variable from 0 to 3. And if somebody is messing around with this slider, say they change it to like 1.5. Well, now this float's updated to 1.5. The random range is now 0 to 1.5. All right. Real quick, I'll just show you that. As I was talking about that, I thought maybe another interesting way might be, let's try and go from like 1 second less than time to destroy to 1 second plus over time to destroy. So let's change our min to max. So max is pretty easy. Whatever the current value of time to destroy is, just add a second onto it. And then that would make our minimum. What do you think? Minus. So whatever time to destroy is, whatever 1 second less than that, whatever 1 second more than that. So what's the issue with that?
destroy time might be negative.
Or it might be less than 1. Right. We might get a negative number for the min. Which I don't know if the destroy method is safety proofed, where if anything less than 0 just defaults to 0. I'm not sure. It's a Unity provided method. I'm pretty sure that one of the programmers was smart enough to safety check it. But we can just do our own safety check. So of the math functions we learned, what do you think might help us safety check that? You could square the number? Yeah, you could. You could square it, and then whatever the resulting square would be positive, but it would be different, which might not be a bad thing. So up here, I had to safety check a little bit on the size because I didn't want the size or the scaling information to be 0 or negative. If it's 0, the shape doesn't render. If it's negative, it like flips around, bless you, and it's like black. So we do have this clamping method. So I could just wrap this all in a clamp method. Oh, I'm sorry, wrap them in. So clamp needs 3 floats, the actual value, and then the min and the max that you want to set it to. So that's the actual value that I'm pumping into it. The min would be 0. I never want it to be negative because that just doesn't make sense. And what's the max? The max is the value itself. That it could be, yeah. Because even if the user drags the slider to 0, then the max would be 0 minus 1. So no, you'd want this to be 0 as well, it looks like. So whatever happens, we're clamping it off at 0. I'm saying the 0 could be, the min could be 0. The max, I'm going to say, I don't think it matters what the max is, but I'll just say fine, time to destroy. Because I don't think there'll ever be a situation where this value is greater than time to destroy. But anyway, you can safety check it so that a negative never goes in to the destroy time. All right. So that aspect, should I go through it again? Is it good? All right. So let me just, I already kind of went through the script quite a bit, but we have here the external libraries that we're using. Final review topic. What's the point of these libraries? What are these using statements? They're also called namespaces. What are the actual ones that we're using? This one comes in by default. These system collections come in. These have to do with like arrays and lists. The clock was using system itself because we're actually accessing the time and date information coming from the system, the operating system. Using Unity Engine gets us all this default like game objects and vector 3s and colors and the update loop and the start loop. This UI library gets us access to interacting with UI elements like text and dropdowns and I don't know if there's other UI stuff, but it gives you access to grabbing or interacting with all the UI via code. And we have event systems here. I made use of that because remember we were checking here. We were checking if the user is currently interacting with a UI element. So I didn't want them to be clicking on a slider, and while they're dragging on the slider, they're spawning all these spheres. So this allowed me to say, no, the user's interacting with the UI with left click or right click, Don't destroy or create or mess around with the game objects that were created. They always go outside of our class. The class is always public. In general, there's just one class per script, and that's what we're doing in this class. And the class name is the file name, or else you're going to get an error. And the class inherits from mono behavior, which is just what the legacy of Unity is built off of. You don't really have to know what this name means, except this gives you all the attributes of a Unity script. Update, start. Then normally you list out your variables, and we can have private or public. And if the variables are listed out here, they're global. If they're in a method, they're local. We can have bools, ints, floats, strings, and then moving outside into Unity, you got game objects and vector 3s and colors and quaternions. Notice how they're colored differently. The UI elements, we got text. You can serialize this stuff, which means even though it's private, other scripts can't grab it, it still appears in the inspector. Anything that's public appears in the inspector, makes it very easy for you to do quick testing as a developer. You can set variables or assign them right when you declare them on the same line, or you can assign them later on in the script. If you do not assign them when they're declared, they get defaulted to whatever their default value is set to. So bools default to false, ints to 0, floats to 0.0. Anything more complicated like game objects, they just get set to null because they're referencing more complicated data structures. You can declare multiple variables per line, and some of them can be assigned, some of them don't have to be. But they have to all be of the same type and the same accessor. You can kind of create little simple UI elements in the inspector. So in this case, we're setting a range. This attribute, this float, does default to half a unit, but we can set a little slider, and it's private, serialized, exposed to the inspector, and the user and the developer can only set it between 0 and 2. If something is not declared public or private, by default it's private. So like global is like internal to the class public, and local is like internal to the class private. Public and private means out to the outside world, to other classes. Can they observe them? Can they modify them, or can they not? So public means you can access them. Private means you cannot. So normally your variables are private, and usually there's some type of getter or setter function to allow others read or write access. If statements can be by themselves. They can have an accompanying else. They can continue on. You can go if else, if else, if else, if else, and then you can go with an else, or you don't have to have an else. You can just have an if. You can't just have an if else or an else to start with. An if statement needs to start with an if, and it can continue on with if else or else as needed. And it can get very complicated, in which case you normally switch off to a switch statement or some other way to do your checks. The if statement uses logical operators instead of numerical operators. They do checks greater than, less than, equal to. Equal to is a double equal sign, whereas a single equal sign is an assignment. In this case, I just threw this method in here, so you're like, well, I don't get that. But if you hover over it, you see that this method returns a bool. And so bools we can use in our statements. True evaluates to do it, false not. So you can hover over stuff and get these quick notes, tooltips. So here we're using the Unity Engine input class, which can be mouse, keyboard, game controllers, touch screens. Those are standard ones. Here we're saying get key, which maps to the keyboard, and we're saying, well, what do you want to check? Well, now they has this whole enumeration, this whole pre-built list for you called key code, which maps every key on a standard keyboard that you can just grab quickly. And if this evaluates to true, meaning if the user is pressing this at this little small fraction of a time that the update loop has captured, we'll do this. In this case, it's a shortcut key to setting which animation I wish to play. And here, they're changing out the type of prefab to spawn. So then this little section here looks for a left click. Get mouse button down 0. The first mapping, which goes to left. If so, we had this idea of arrays, another Unity data structure. We're using the camera class, shooting a array or a vector out from the screen into this virtual world we're creating, and from the location wherever the mouse is on the screen. And then we create this hit data structure, and we'd say if this physics shoots out and hits something, then we do another check. Well, if we're clicking on the clock, if we did hit something and that object is on a layer, and that layer is 11, which if I go into the clock here, we have these layers, and I created my own custom layer, which clock face maps to integer 11. That's why we're checking 11. Then we'll run this script on the clock, which updates our clock time. So this allows me to navigate through whatever this raycast hit object was. You have to jump to the transform of this object. And I'm getting the component on at the clock. So which this script lives on the main parent object. So if we click, we hit one of these things, and it says go up a level. If you go up a level, there's going to be a clock script. And then on there's going to be an update time. Pass in the rotation of Y of this little part of the clock, and from that I can figure out which time we should go to. Then we do a right mouse button check, and we make sure we're not clicking on the UI. If so, we shoot out array. And if we hit something on layer 12, which I've set my prefabs to, so if I go to my prefabs, they're on layer painted object, which is layer 12. If this object is on that layer, I know I painted it, and I know right click is for destroy. So destroy it, and then we're spawning an explosion and then destroying that a second later. So that's what that little white poof is afterward.
That's automatic explosion?
No, it's a prefab I made. So if I go up to click detector explosion, I click on it, it's just this particle system, which all I did was go game object, and where is it? Effects, yeah, particle system. So if I just move it over, what's happening is this little window is like simulating time just for this particle system. And a particle system is just shooting out these little 2D images, these little sprites. and you can go there. It's crazy. You can change the color, the speed. You can make it look like fire, smoke, fireworks, water, steam. You can do a lot with particle systems, but this is the default one. I didn't even touch it. All I did was drag it from here, dragged it over into my project, made it an external file, and that's what plays for 1 second, then it gets destroyed. So this, you know what, logically, oh no, I should check this first. So basically what this is, it says if the user is releasing the left click, meaning they're ending a paint stroke, then our last click position is going to be zeroed out. The reason for that is I check before the user clicks again. Because I remember the first time they clicked, we had it would just spawn this crazy first paint stroke because it's reading the last value of our last paint stroke, which could be anywhere in the screen. So to help fix that, whenever the user releases the left click, we zero out our last click position variable so that our next first click doesn't get all crazy sized. Then we see if the user is currently painting, currently holding down the key, that they're not interacting with the UI. And I happen to do this X cutoff, which now it's set to 0. It's not actually functioning, but this was doing the check. If the mouse position is getting too close to the left side of the screen, don't actually paint, because then it starts painting over the UI. But now that I can move the UI away, and the paint strokes I moved behind the UI anyway, it's not that big a difference. So I just set this variable to 0, meaning it paints the whole screen. So what we're happening here is we're figuring out where should we start painting, because we know that the user clicked. So we're just shooting a array out through the mouse position and then adding a distance from the camera. So we know the X and Y, we just need a Z off of the camera. We're setting that manually. That's going in our click position. We're checking if we should randomly spawn an object. Then we spawn an object. Then we morph it based on the last paint stroke, or last object we placed. We're colorizing its children, checking if it has an animator, setting the animation state, if it should be random, setting it, checking random time, setting the time, storing that data. We also stored the data of the children color. Parenting it to click detector, seeing if we should put a time destroy on it, recording our last click. Then no matter what, that's why this is outside of this if statement. No matter what, we're always tracking where the mouse position is. Then we have a bunch of change methods, which are generally driven by the UI. And just for the destroy button. And that's it for the script. We do have this little prefab data script here that we connected to our root of our prefabs. We also rebuilt our prefabs so that our animations don't mess around with the user interface grabbing it, the roots of it. So as long as you're animating off of the root, you're good, all the children. And this data records a float for the animation and a list, or as many colors as we need to record for as many children. There's a UI animation script sitting at the root of the UI. This is driven by that hide button, and this moves UI left to right. And for his project, his UI is sitting on the bottom there, so I customized the numbers. All we did was change these numbers, and now it moves from top to bottom. And this script, just be aware of, we can check if we're running external to Unity, it's actually built and running somewhere else, or if it's running within Unity. We have this idea of an enumerator, or coroutines, or the fact that multi-threaded programming, that we can send off our own little loops and they can do their own thing on their own little time sequence and then kill themselves. So this is part of the UI. We're checking which direction we should go. And once we do that, we run into this coroutine, which says, hey, for however long it takes, go away from me. Turn off the hide button so it doesn't get crazy with user spam, but just move this over a certain amount of time. So animation uses the idea of run off on another thread. And then this while loop keeps going until the distance check is at very minimal, meaning the object has moved to its end location. And then we kill it. So while it's moving, we use this idea of a yield return null. Just pause this mini loop while we continue with the rest of the update loop and reopen it, reawaken it on the next update loop after you've just moved this object just a microscopic little amount. And we got a script somewhere. Oh, the clock script. The only other script that's functioning in here is this clock script. And this is just pulling it. Notice the only different library using system. And everything here you've seen before. Here's a transform. You've seen that. In this case, on awake, which is similar to start, awake and start are run once when the object first starts or when it first awakens. And here we're recording all the time from the system time, doing some checks how to update AM or PM. Then we have our little update loop. Notice this update loop I wrote private, but you know when you don't see that, it's still private. Like down here, void update continuous or discrete. And this is just updating the second, the minute hands, and the hour hands. And then this update time, if we click on one of the aspects of the clock, this updates the actual daylight. And we figure out if we click that AM or PM button, just flipping 12 hours at a time, this is just figuring out that math. And here we just have a getter, get the hours. And the only major part left really is that remember that this daylight system, I parented it and I rotated it in such a way that when this light source is at 0, it's pointing straight up for midnight. Very easy to do math now, 0 to 360 based on the time. So I'm going to undo that. I just had some random rotation just to keep the scene lit, but this gets overwritten when I first click play. And then the parent helps be offset. And we said these are turned off, ignore them. So the idea that you need one camera in the scene needs to be your main camera. You need to view into this, needs to be rendered to the graphics card. This click detector is like a majority of our functionality. This event system is created by default. It helps monitor the user interface. And my canvas, which remember it's in world space now. It's actually sitting here in the world, not just rendered to the screen. So if I take this quad, I could turn it off. You might have something like this. This is our like canvas behind it. But if I delete all this, shrink that, I have my camera, I have my light source, I have my click detection manager, I got my UI, and its event system. That's it. And then I'll shrink up the project. Here's what the project looks like, all the external files. If you right click and say show and explore, you can see that these are all just a bunch of files that are used to build. And if I pop up a level, this is the root of the project. We work in the assets folder. There's a whole bunch of other stuff going on here. You don't have to worry about it. You work in the assets folder, and this build folder is when you build stuff out. You build stuff out by going File, Build Settings. You have to select the scene you want to build. Usually we're just doing one scene. You guys are building for WebGL. think I was testing an APK file on the phone, an actual mobile version of it. But you're building to WebGL. When you build it, you have a bunch of folders of files. You can test locally by just going to the build, right-clicking on index, say, here we go, open with Firefox, and it runs fine. You can test it, everything looks great. Once you test it and it's great, you zip it up and put that in the HIO.
Can you go over UI animation scripting?
Sure. So the script lives on the root. So to have this all work well, first off, the UI needs to be in world space. So once you switch over, it's going to be super big. Just 0 out X, 0 out Y, centered up to the camera. And notice my scale used to be 1. I'm down to like 2.5%. So you're going to have to scale it way down. Just try 1%, and it should be viewable on your game camera, on your main camera. So notice if I scale it up, it's like way off, but I'd scale it way down, and then I kind of found the value that felt right was, for me, 2.6. And then your X and Y might be different, but I was able to just position it at 0, 0, 0. But whatever that is, it doesn't matter. You just record that information here. So anyway, I built this hide button, and the button just calls move UI. So build the button, and I built it so that when I found wherever I want to move it to, at least the button still pops off a little bit. I can still click on it. That's why it's kind of got this over tab look to it. So let's see, the only new namespace or library is uniengine.ui. And if you notice on Canvas World, all the way down here, the script is live and it's sitting at the root of my world space UI. All right, so let's see. I have a bool. By default, it's false, so is hidden. It's by default, it's shown. So I set this to false. I got this enumerator. I just called it coroutine. We're going to keep track of that later. I got a public float, the length, the time of the animation. I defaulted it 2 seconds, but it's public. You can change it later. I have some vector 3s. Whatever my show position is, whatever my hide position, whatever my current, or the start looks like position is for whenever the hide button is clicked. Then I have a button variable. This is the hide button on my UI. And so that's why when I click on the script, anim time is a float, defaults to 2, and I actually dragged on my button hide, my hide button. So if I click on it, it's just a button, and it runs a method. It doesn't pass anything. It's just calling move UI. That's it. So when we start, we have to set what our show position and hide position is. So I just moved it manually and found that, okay, I really like it at 0, 0, 0. You might be somewhere else. And I really like it when it's hidden around -6. So X, Y, and Z. Figure out what they are for your show and hide. It can be any positions. Doesn't matter. You just set them right here. So remember, 0, 0, 0 is already a pre-built vector 3. I don't have to create a new vector 3 for that. I can just say vector 3.0. But -6, 0, 0 doesn't exist yet, so I have to do new vector 3.
What was the purpose of making public button, hide button?
Making it public. Well, I'm gonna disable it when it's moving.
No, just like making that very.
This here, because down here, I'm going to disable it and then enable it again. So the purpose of that is if I click play, when this is moving, notice it's gray. and I can't do anything. Otherwise, the user can just keep spamming on it, and I have to make my script even more safety proof. And it'll start breaking. Like, my script isn't robust enough to let the user spam on the button. So I disable the button when it's moving. So this just checks if we're not in the editor. Then this little trick says, no, set the UI to hidden, move it to its hidden position, set is hidden to true, and then call my move UI. Just move it out so that the user gets a notion of, oh, this UI is movable, and I can move it out of the way if I want it to open up my paint space. So when the button calls move UI, we just do a check on the bool. If it's already hidden, we want to do something to move it to show state. Else, we want to do something to move it into the hide state. So if it's hidden, our coroutine is going to be moving UI, and then we're going to pass in the show position. Else, we're going to pass in the hide position, and either way, we're going to update the bool to whatever our ending position is going to be. If we're going to move into hidden position, or if we're going to move this into move to show position, then is hidden is false, and then here we're going to move to hide position. So is hidden is true at the end of it. Whatever the case, we're going to start this coroutine, which shoots off a separate thread in the main loop. The main game still goes its merry way. You can do whatever you want while this thing figures out how to move itself off on the side. In that case, it's a numerator. It's private. We only call it from here. This is public because the button calls it. And we're passing in a vector 3, which was show or hide, whichever direction. I'm just calling it our end position in this situation. So I'm going to keep track of the time that this little separate time loop is running, which when it first starts, it's starting at time 0. I'm going to record in its start position, which this script is at the root of our UI. So the transform.position is saying this is the position of the UI when we first start. I'm going to disable the hide button so the user can't spam. And then we are in this while loop for however long anim time is, in this case 2 seconds. So while the distance, I don't need to do the math. Vector 3 has a method for me to tell me the distance from one position to another. So while we're wherever we are within this loop, we can be anywhere from our start position all the way to our end position, wherever these two locations might be. Whatever that situation is, it's going to be greater than 0.1. In this case, I'm going from 0, 0, 0 to negative 6, 0, 0. So when we first start, that's a very simple distance because it's just along, I can ignore the y and the z. It's 6 unit difference in the x. So when we start, this distance is 6 units. 6 is greater than 0.01. We're going to go in. So we use this lerp, linear interpolation, which says, give me a starting position and end position, give me the amount of time you want to get there, and I'll figure out what position you're currently at along the way. And linear just means in a very even way. Like remember in the animator we have all those curves. It's not doing all that curve stuff. So you pass in a start and end and where you currently are along your journey. So elapsed time is 0. 0 divided by our anim time, which is 2. So we're at a 0 point in our journey. We can go from 0 to 1. 0 complete to 100% complete of the journey. We haven't started the journey, so we're basically at start. It figures out we're at start position. And then it updates the position of the UI. And then time delta time is the amount of time that's passed since the last time we ran this method. The last time that the update loop called it. So it's a very small fraction of time. it's something like 0.003 or something, whatever. We add that in, and then we hold. We put this method into freeze, into sleep state, until the next time the update loop comes around. And then we do a check. We don't do this stuff again. We're already in this while loop. We just do this stuff once. We're in the while loop. We've moved a little bit. So instead of maybe 6 units, maybe we're like 5.95 units off from our end spot. And that's still greater than this. We go in. Now we have a small little fraction divided by 2. So our journey has just started. Maybe we're at like 0.05% into our journey or something like this. And it figures out where we are on that journey from start to end. And it updates our current position. And then it adds a small little fraction of time, and we wait. And eventually our journey goes from 0 to 1. From nothing at all completion to full completion. And at a certain point, we're so close, we're just a microscopic hair off that end point, maybe at 5.99 x 0y 0z, and our little gap between our ending position and our current position is so small that we do not go into the while loop. This comes to false. We exit. We are done. And our hide button is now interactable. And we've ended our journey. And we are done with this coroutine. That's it. And then you're allowed to click the button again, and we figure out the logic, and we do the move. So that also was my final review. Like, I went through like all the scripting knowledge that you would really need to know. And again, you can go here. I've listed out a bunch of topics, and if you need, there's a whole bunch of quick little videos. The Unity interface, user interface in general, all the user interface elements, physics, animation, scripting. You're good.
The last script with the UI that you did it have to be a separate script, or could it have been done with the original script?
What part's that?
Like that whole script with the UI animation, did it have to be a separate script? You couldn't put it in the other script?
I could have shoved it into the other. Yes. You can make these what they call monolithic classes, which do all this crazy functionality or multi-use functionality, but it gets very cumbersome, hard to read. Right. So you want to break them out like into separate classes as much as you can. So it's very easy for me to understand, this deals with animating the user interface. Mm-hmm. And I know when I need to update that part of my app, it should be easy for me to find the script that's dealing with that. But yeah, you can break apart all these scripts into separate files as much as you want, or you can combine them all. And it's just about the ease of development, how easy it is for you and your team to develop. All right, I'm going to stop the video.